Hello everyone, myself Vanilla. I'm pursuing my MCA in VTU Belgavi. Today here I would like to discuss about the project work that I have carried out in my final sem of MCA. The title of the project is Emotion Detection of Textual Data Using Logistic Regression and Random Forest Classifier. Firstly, the introduction of this project is emotion detection in natural language processing has become increasingly a vast amount of data is available on internet to identify emotions in many applications including video, voice, text and image. Numerous techniques have been used. Identifying emotions in applications is crucial, involving human machine interaction, as understanding emotions can enhance the success of robots and other systems. However, identifying emotions in video and images is computationally expensive and challenging due to large internet explosion development in text document. Emotion detection from text is becoming more and more crucial. Large amounts of textual data can provide insightful conclusion by studying and comprehending the emotions portrayed in writing. The substantial developments in machine learning techniques have increased the capacity of machines to comprehend human behavior. Emotions is on most relevant important components of human behavior. It may benefit the machine to identify human emotional expression. The volume of data collected on the internet has made emotion identification a difficult topic with regard to natural language processing, that is NLP. Various strategies have been devised and used to identify emotions in many applications, including voice, video, text, and picture. Furthermore, ability to recognize emotions may help the machine better in scenarios involving contact between human and technology. Emotion detection in photos and videos is challenging and computationally costly. So, emotion identification from text has become crucial since the amount of written documents on the internet has increased. So, the problem statement and scope of the project is the identification and categorization of emotional states from the user text can arise different difficulties, such as the small size of the baseline dataset that are only loosely annotated with emotional classes. However, recent advancements in machine learning based neural network models for emotion recognition have produced encouraging outcomes in number of domains, including emotional analysis from audio, video, and text. The work of detecting an emotional state from the user text is one that we view as multimode classification problem. A training dataset TRD is labeled with emotional states of joy, sadness, fear, anger, surprise, shame, neutral and distressed. Each and every text message from the user has a particular emotion. The goal of the project is to create a computer module that, after being trained on a particular trained data, the model can categorize incoming user text into various emotional states. Objectives of this project are: human will be expressing their emotions through faces, gesture, words and written communication. A content-based classification challenge is the identification of text emotions. In this project, I am using Python and machine learning to tackle the text emotion detection problem. The duty of content-based categorization in machine learning, which is natural language processing, that is NLP, is employed for the detecting of emotion from textual data. The ability of a people to communicate his or her emotions a number of different ways makes it a challenging to identify those emotions in user text. In this project, I wish to develop an application for text emotion detection or text emotion classification using Streamlit and Python, which will be taking our input and classifying that text into emotions like joy, sad, fear, neutral, anger, shame, etc. using natural language processing. Literature review. In the paper, the emotion identification utilizing supervised machine learning to analyze data. However, it is a promising approach that can precisely predict the emotion represented in the text. Several different machine learning approaches are used. In the second paper, to tackle the issue of emotion detection, module requires data to be labeled by humans. The following model, word to vec, serves as text analyzer. Furthermore, algorithms like k-means and vectorizer is used. The input for this is user text and the user emotion is predicted. In paper 3, the purpose of an emotion detection system is typically whether a person is thinking positive or negative. The text classification method will be employed in this case to identify the emotion in the text, whether it to be a social media platform or in any regular survey run by different companies. As a result, text classification in machine learning is crucial to our daily lives. To categorize information to proper emotional context, we have employed the bittered technique. In paper 4, the study to employ RNN LSTM to classify people's perspective into negative or positive categories according to the dataset and try to compare the result to different machine learning techniques, including SVM, KNN. The study resulted that RNN LSTM has the highest accuracy than remaining modules. Next is the system requirements that are useful for this project. Firstly, the software requirements. We need an operating system that is Windows 7, Windows 8 or Windows XP. Coding language used is Python. The browser we are used to deploy this is Google Chrome, and the software used to write the code is Jupyter Notebook and Python IDE. Hardware requirements are processors Intel Core i3 or higher, memory RAM of 4 GB minimum, Wi-Fi support is must. Next is domain of the project. The domain used in this project is Python or machine learning. Python is an interpreted high-level dynamic programming language that is free and open source. In addition to procedural programming, it also offers object-oriented programming. Python is dynamically typed language. Therefore, declaring the type of variables is not necessary. Some of the features of the Python are free and open source. The Python is freely accessible on the official website. Python download being open source, it implies that public may access the source code. Therefore, you may download it, use it and share it. Easy to code. In comparison to languages like C, C Sharp and others, Python is fairly simple language to learn. The Python is incredibly simple to learn and anyone can master its fundamentals in matter of hours or days. Furthermore, it is a developer-friendly language. Object-oriented language. Object-oriented programming is Python core characteristics. Python supports classes, objects, encapsulation and other object-oriented language ideas. Next is Python standard library. The Python standard library contains all the syntax, semantics and tokens of the Python. It comes with a built-in modules that let us user access important system functions like IO and few other core modules. The Python standard library contains over 200 essential modules. All these works together to make a Python high-level programming language. Numerous other libraries exist in Python than just this one, which makes the life of a coder easier. Let's take a closer look at a couple of libraries I utilized for this project. Streamlit, a Python library that is used for unique web-based data science and machine learning application, can be easily created and shared using this open source Python module. You can create and deploy effective data apps in a matter of minutes. Next is Seaborn. This library deals with the plotting of numerical data. It is used in data analysis. As a result of this, it also generates open source libraries that makes extremely detailed graphs, scattered plots, graphs and pie charts. Next is Pandas. Pandas is a vital data science library. A collection of analytical tools and custom high-level data structure are available in this free machine learning toolkit. It facilitates simpler data administration, cleansing and analysis. Pandas supports a varieties of operation including data conversion, visualization, aggregation, iteration, concatenation, sorting and more. NumPy. The most well-known library is called NumPy, which stands for numerically Python. This well-liked piece of machine learning software is capable of working with big matrices and multi-dimensional data for rapid computations. It features mathematical functions built in. Even frameworks like TensorFlow use NumPy for core tensor operations. This library array interface is one of its key features. NeatText is a simple NLP package for cleaning text and pre-processing text data. It is used to clean sentences, extract emails, phone numbers, web links and emojis from sentences. sklearn is a well-known Python toolkit for handling complicated data. It is compatible with a variety of supervised and unsupervised methods, including linear regression, classification, cluster, etc. This library operates with combining NumPy and SciPy. Next are the various ML classification algorithms used in this project are logistic regression and random forest. Firstly, logistic regression. To predict the probability of a target variable, logistic regression, a supervised learning classification technique, is utilized. Since the dependent variables object in distinguish in nature, there are only two visible classes. Simply explained, the dependent variable is one where data is input as either 1 stands for success or yes, or 0 stands for failure or no. Mathematically, a logistic regression module p of y is equal to 1 as a function of x, one of the most fundamental machine learning algorithm. It may be used to solve a variety of classification problems such as spam detection and text emotion recognition. This is a structure of logistic regression in which we are having two phases, training and testing. First is training, emotion data and labels are into logistic regression. From this, we are giving a testing data, that is emotion data unseen, that is sent to trained classifier, and lastly we'll get the emotion label. Random forest. The random forest method is a popular machine learning technique for detecting text emotion. It is an assemble learning technique that combines many decision trees to provide predictions. The construction of the random forest classifier is shown in this figure. This is a decision tree 1, decision tree 2, decision tree n. We will be getting a result from decision tree 1, that is result 1, decision 2 as result 2, and so on up till decision tree n, result n. The majority, OT and averaging will give you the final result. So this is a construction of random forest. The following is a description of random forest classifier method for text emotion detection, that is data preparation. A group of text examples with the corresponding emotions attached should be gathered. Pre-process the text into eliminating and any extraneous data, including stop words, punctuations, and special characters. Transform the pre-processed text data into a numerical representation using methods like bank of words or TFD-IDF. Random forest model construction. This model is made up of number of trees of decision making. Before each tree is formed, a subset of the training data and a subset of the features are randomly selected. The data are recursively split depending on the chosen characteristics to create the trees of decision making, with each split seeking to minimize impurity or increase information gain. Next is assemble learning. To arrive at the final prediction, the random forest algorithm aggregates the predictions from all the decision trees. Each decision tree in the forest predicts the emotion label for a particular text sample. The majority vote of all the decision tree determines the final forecast. Next comes the training and prediction. The random forest approach creates a number of trees of choice during training, each one using a unique subset of data used for training and attributes. Using samples and feature subsets, the decision tree are trained separately. The random forest approach, which averages the prediction of all these trees, determines the final emotion label for a specific text sample. Next is module evaluation. The trained random forest module performance is tested on different training set. A number of testing measures such as accuracy, precision, recall or F1 score may be utilized to determine how well the model can predict the emotion of text sample. Next is methods used for text-based emotion recognition system are keyword-based technique. A keyword-based method is a way to extract all the instances of a given term from the input text as a substring. This topic has been investigated in the past and many methods have addressed it. This approach is predicted on certain emotion keywords. This method's accuracy depends on sentence phrasing, which serves to locate the emotion keyword and a dictionary of emotion words. The list of the words is separated into groups based on present emotion classification, including sad, joy, distinct, fear, and surprise. The following five phases make up the key-based emotion identification technique, which requires a text document as input and produces a emotion class as an output. Data is first tokenized and stop words are removed, after which the data is labeled with various terms like verb, noun, adjective and adverb, among others. The subsequent stage will identify the appropriate emotion word and the intensity of this word will then be determined. The sentence negation has now been explained and the emotion class contained in the sentence has been extracted. The process flow for the keyword spotting method is shown in this below figure. Firstly, we'll be having a text. Then next is remove, stop words and tokenize. Then tagged words, identify emotion keyword. Next comes analysis of intensity, check negation and emotion. So this is a keyword based technique flowchart. Next comes the proposed system. Proposed system is simple to comprehend and use. Both learning and keyword research utilize this technique. The keywords in this module familiar to identify the emotion in the input text. Therefore, with the textual input, the algorithm will provide a more accurate results. In order to determine the emotion from the textual data, the probability value for subsequent processing is done. The procedure below is suggested. So this is the flow of proposed system in which we are having user input. Next comes text pre-processing, then feature extraction, emotion classification, and output or result. There are some steps for this algorithm of proposed system, that is input is take user text, output is a emotion. First step is take input as user text. Second is to pre-process the data. Third is to convert the pre-processed data into numerical features. Fourth is a machine learning model predicts the probability of the input text belonging to each emotion class. Next is the class which highest probability is selected as the predicted emotion category for the input text. Finally, the output of the system is the emotion. Next is design of this project, that is the system architecture. Whole is the system architecture in which we'll be having again training and classification. Training, that is label, that is directly connected to machine learning. Then next we are having an input, then text extractor, and here we are having a sample text, that is I did not feel humiliated. This is a sample text and that is also connected to machine learning. Then next comes a classification, that is input. After input we are extracting that input, and again we are having a sample text that I am feeling gauzy, that is also a sample text. Then this text is sent to a classifier module, and then the output of this is the label and a module extraction. So this overall, this is a system, this architecture of this project. Next comes the flow of working. So start, here is a start, then we read a sentence from the data set, then we pre-process the sentence, then phrase the verb identification, then emotion keyword is analyzed and intensity is checked. After the check of intensity, we go for a negation check, and after that we will be calculating the score of the emotion and give the output based on that score as the emotion of that particular text, and this is end. So overall this is called a flow working of the proposed system. So here is the implementation of this project. In the project, I am using a Python for text-based emotion detection system, as Python provides a different number of modules and libraries for us for use in variety of applications, especially for text processing. The NLKT, that is Natural Language Toolkit, has been used. The necessary libraries used in this project are as follows, that are Pandas, NumPy, sklearn and Seaborns. So now in implementation, firstly this code is used to load the data set. So we are loading the data set with a function called pd.read underscore csv. Next, we are using data pre-processing. Data pre-processing is nothing but removing the unwanted words and all is called a data pre-processing. That is, remove the user handles. For that we will be using this code, and this code is written to remove the stop words. The third is the splitting data into input variables and target variables. So here we are having two, that x and y. X is a features are the attributes and variables extracted from the dataset. These extracted features are used as input to the module during training, and Y labels are the output of the target variable. So you can see here X is a clean text and Y is an emotion. It means X is a variable extracted from the data set and the Y is a target variable. Next comes creating a train and test sets from the data set. A train set and a test set need to be created from our data set. From the train data set, the module will learn. We will access the module's effectiveness and gauge its capacity for knowledge using the test set. For this, we are writing this code. And next comes the training the module. Training using logistic regression, we are going to use this code. And training using random forest classifier, we are using this code. And lastly, we are trying, after all this, we are trying to make a prediction. In the sense, we are writing here a text. By using a function lr.predict, we are predicting what is the emotion of this present in this text. After predicting, we are saving this output in this job.lib, that is useful for us to get the output, like what is the emotion detection and a predicted graph. Next is the result. The result of this project is that when we give the text as an input to the system, then the system using logistic regression and random forest classification modules, we get the detected emotion, and also it displays the prediction probability graphs as an output. So now, as and when we run our project, we will be getting this screen, that is screen console, to enter an input, or we can say this is an home screen, which after deploying the project, we will be able to see this screen. Inside this screen, we are going to give the input, that is I am feeling awesome. In the sense, in this text type here, that is text area, we are going to write our text, that is I am feeling awesome. And then we are going to click the submit button. After clicking the submit button, you will be getting original text, that is what is written in this text area will be as it is printed here, that is I am feeling awesome. Then next, you will be able to get the emotion detection, that is joy, with a score of 0.47 610, and also you'll be able to get the prediction probability, in the sense how much percent, or else how much, what is the, which emotion is having the highest score, or which is having a more intensity of emotion category in this text, you'll be able to recognize in this present graph. Especially here is the graph which you can maximize and see. We have different kinds of emotions in which we have the maximum score for joy. So simply this graph, it represents the amount of emotions used in a sentence or a paragraph. So finally, conclusion of this project is that a new feature selection schema is proposed to investigate the effect of the selected features in emotion recognition from textual data. In this project, I have used logistic regression and random forest strategy for emotion detection, and the result is that emotion detection using logistic regression has an accuracy of 88%. This technique will enable an AI powered robot to understand human text and respond accordingly, which allows you to better understand human emotions. This system is used to learn about customer reviews of the projects, which will assist us in understand the value of the products and any website. In addition, it is used to in social media analysis, mental health monitoring, sentiment analysis and feedback analysis, and also in text emotion recognition. Thank you.